Hello everybody, this is second easy calculus. The first one we talk about derivative is slope, and we used algebra to calculate the slope, and that's become the derivative function. Okay, now that's for algebra folks. Now you are proud calculus folks, and the calculus folks get a new way to calculate slope. Okay, so new way is this is derivative y prime, or you can write f prime. Okay, this looks familiar. Yeah, y prime equals f prime equals d dx fx, or you can write dy dx, or you can write d fx dx. Any of this writing is okay. Okay, so why this become slope? Because when you have curve, you take x and delta x, and this is delta y. So average slope is dx dy dx, right? And we make delta x small, very small. Okay, then this slope, this is slope, right? Close to m, almost m, become very close to m, right? So this, we get that. Okay, yeah, so when you make delta x almost 0, then this eventually become slope m. So we write this way: delta x goes to 0, delta x goes to 0. Cool, right? Okay, so this cube derivative. So what is this limit? What the hell is this limit? Why you need a limit here? Huh? What's the meaning of limit? You can flip around the math textbook and find out what it is. Okay, they don't tell you what it is. They just say, pretend you learn and you know now. You need to write the limit, and delta x becomes 0 below the limit. Well, I tell you the secret why you cannot answer. Okay, you run real number, right? It's made of what? Rational number? And irrational number. And the real number is made of this too. Rational number is anything represented by integer ratio, right? And irrational number is everything else. The secret is there is another kind of number. Well, it's not imaginary number. Okay, imaginary number is outside of real number. Another number is called infinitesimal number. Okay, this mathematician invented the name, luckily, so we can use this name. Well, what is a real number? You know the real number line? 0, 1, and 2, negative 1, so on so. Any number sit on this line is a real number. This line means the number has greatness. Means you can compare from here small to very large. Okay. If you have an imaginary number, suddenly you cannot compare. Okay? Because is 2i larger than 2 or 1? No. So imaginary number is outside of real number. Real number is anything on this line. You look at this line very carefully. Yeah, you have square root of 2. You can even have pi. They all on this line. Let's see, rational number is rational number. You look at this, something close to, very close to number 2, like 2.000000001. Yeah, that's a rational number. Okay, what is infinitesimal number, which they don't tell you, they don't teach you in before calculus, but they use it in calculus. Without teaching you, they use it, so you get confused. Thanks for that, right? Okay, what is infinitesimal number? Infinitesimal number is, for example, something very close to 2 but not 2, infinitely close to 2. So this one, you compare with this one, this is bigger, and we express this infinitesimal number by putting plus because it's larger than 2. But any number you can write up, rational number, irrational number, this guy is smaller than that. Where is it in the line? Yes, it exists right next to number 2. Next to number 2? What is next to number 2? 2.0000 all the way forever. Okay, so it's go infinite. You bring the infinite concept into the number. This kind of number is also existing with infinite concept. Here, rational number, irrational number, okay, you don't need infinite concept. But if you bring in infinite number, suddenly real number has another new number called infinitesimal number. Well, 2 plus minus 2 is positive. Okay, let's say some amount epsilon, but this is very close to 0 here. Okay, remember, something very close to 0. So what this formula is asking is to turn this into infinitesimal number, but they didn't teach you what infinitesimal number is. Okay, this is 0 plus. It's not 0, larger than 0, but it's smaller than any number. You bring in 0.0000001, this guy is still larger than 0 plus. Okay, so this means they use this number. Then what happened if you use that number? Okay, let's do say fx is ax square, right? So fx plus delta x is ax plus delta x square. So you have fx plus delta x minus fx divided by delta x, right? So this is algebra, right? So it's going to be ax square plus 2x delta x plus delta x square minus a x square. So this goes away, right? And delta x. So it's become 2x plus delta x. And this is not derivative of this. Okay, they say use delta x, change this into infinitesimal number. Okay, so this become 2x plus some infinitesimal number. Okay, so what we did so far is 0 delta fx delta x. We try to do derivative, and this is not enough. This still has this guy hanging. That's where the limit coming. Limit means remove this kind of infinitesimal number. Okay, means this fx is very close to 2x. So if you have, say, real number 2x here, you are looking at right next to it because of this guy. Okay, and limit tells you, okay, forget about infinitesimal number. What will be the number, ultimate number next to it, which is 2x. So if you have a limit, suddenly this become 2x. Here you go, you get derivative. So what this limit, the limit means, this guy means convert delta x into infinitesimally small number. Okay, now limit means after converting it, calculating it, get only the number you can specify on the real number line, which is 2x. Okay, so that's what it is. It's compound statement. Mathematician just compacted this limit. If you write in English, derivative equation become like this. Okay, take non-infinitesimal number after you calculate derivative ratio. This is a ratio. Okay, derivative ratio using an infinitesimal number, which is delta x, 0 plus. Okay, delta x is not 0 plus. Delta x going to the 0. This is the only way you can indicate number. Infinitesimal number, you cannot specify, you cannot say it's here. You have to say going to 0. That's infinitesimal number. We can say 0 plus. Okay? If it's a negative side, we can say 0 minus. Okay? So that's what it is. Mathematicians just compacted into this, and that's what derivative means. I hope that clarify what you learn in the calculus. Okay, so then what is this nonsense? What those dx, dy and stuff? Okay, don't get confused. Okay, d over dx is just another way to say this is f prime. Okay, but that's not what it is when you have division here. This is actually dy divided by dx. So if you say delta x goes in 0, delta y, delta x, dy dx, this become infinitesimal small number. This become also infinitesimal small number. Then are they infinitesimal number? No. They are real number. But you said equal. Yes, the ratio is equal. That's a tricky part. They don't tell you. Okay? Yes, delta x, delta y become infinitesimal small, but delta y, delta x can be 6 over 3, which is 2. Okay, so slope is 2. Then graphically, suppose you have slope, and here you start a new coordinate, which is delta x, delta y, and this slope is m, so equals m dx. Okay, so you start a new coordinate here, dy equal m dx. Dx and dy can be any value, but ratio is m, which is this one. Nowhere in this formula said dy and dx are very small infinitesimal number. No, the ratio is equal. Only ratio is equal. Okay, so this is another part. You get confused because they don't tell you. The math textbook or even teacher doesn't tell you. So for example, when we do this, limit x equals 0 and sine x over x, right? This means you make x infinitesimally small number. After that, take only the non-infinitesimal number. So sine x is x minus x to the third plus x to the fifth, so and so, and divided by x. Sine x over x become 1 minus x so and so, 1 plus or minus some infinitesimal number. Okay, so when you do x equals 0, then answer is going to be 1 plus infinitesimal number, and because of the limit we take this out, so answer will be 1. Okay, so make sense? So here's the instruction. It gives you instruction, take non-infinitesimal part of the answer after you make x infinitesimally small. That's what it means. Okay, so you take infinitesimal number, non-infinitesimal number is 1, answer is 1. So this is what the limit means. Okay, the same limit used for calculating derivatives. I hope it makes much clear what the derivative means and why they use limit. If you have the new number, infinitesimal number, that number is a real number. It just you never learn it. It's because it's use concept of infinite. Okay, and when you introduce infinite, there are a lot of funky stuff you can do in the math, and one of this is this going to 0 kind of way to express the number. This is the new number, and using this number you calculate, and you don't want to leave that in order to continue your algebra, right? So you have a limit. The limit means, okay, after you calculate, take out all the infinitesimal number stuff. So that's what it is. Okay, if you like this video, please subscribe and give a good review, write a comment if you like, and just wait for the next easy calculus number 3. This make your life much easier learning calculus, or even you learned long time ago and you always remember, oh man, calculus, I don't understand, it's just confusing. Now this make it very clear for you. Okay, see you next time.